So, and this will be our last talk before the lunch break. This is from Po from Inter.link. Po is lead CI/CD developer all around the customer portal, and he will give you an insight about their learning curve with their automation and their systems which they set up. Please welcome Po on the stage for this talk.
All right. Yeah, so I'm Po. I'm here to talk about evolving Inter.link's software delivery. So what is this about? This is actually just going to be a story. So a lot of just random stuff that happened over the years. And of course, with any story, we have to start by setting the stage. So just give some context. So yeah, as I said, Inter.link is obviously my employer. We have what we are trying to do in Inter.link, so we're basically a carrier, but we have a few things that's important to us. So first thing for us, sustainability is important. What this means is that we try to track our usage, carbon usage, across everything that we are doing, and then of course trying to reduce it and then offset when necessary. And for this to happen, we kind of need to make sure that actually we try to automate everything. So next point, fully automated. Because by doing so, it allows us to have all this, track all these usages a bit better. But also, it's also definitely just a better experience for our customers. And the next thing that we want to do is also to make sure everything that we do is transparent. So when you go to our portal, you get a service from us. You can see the status of your service, you can see the usage, you can see the pricing, we want everything to be transparent. So how do we actually do this? We have a portal, I just mentioned it. So if you go there, you just go there, you see the dashboard, you say click add a service, we have a bunch of services, IP transit, IP access, the usual stuff. And then say you click on IP transit, you will be able to go there, select a port in a specific location, configure a bunch of stuff for your BGP session and whatnot, and then you can order. So essentially what we're looking at is, if you just distill it down to boxes, it's just this, right? You have a user, and then you go to the portal front end, and you do stuff. What happens after that? So when you finally get to place your order, yeah, we just send like a JSON payload back to our portal backend API, and then it does more stuff like validations and whatnot. So that's basically it. Yeah, not really. So after that, the portal backend, after doing all the validations and processing, sends another payload back. So now we're going back into our internal systems. We call the first backend API, internal backend API, Cortex. Cortex does a bunch of stuff. So now going into the internal side of Inter.link, it does a bunch of stuff. So one of the things it does is it just goes to our ERP and create the necessary resources about the service that just got ordered. And then obviously, because this is a network service, so we also use Netbox. It goes to Netbox and creates a bunch of stuff. So if you're like doing IP transit, it could be like allocating prefixes, IPs, the port, BGP sessions, and whatnot. Yeah, this is obviously not all because we're still at Netbox. What we do after that, we have another system called Iridium that gets triggered. So once all the stuff is there, we trigger Iridium, which then reads from Netbox and pulls all the necessary information out. And then after that, it kind of translates them, does some processing, translates them, and exports them out to Git. So at this part, this is basically just the host variables for Ansible, which we'll see right here. So once everything lands in Git, Cortex does the next step. It triggers what we call the deployer, which basically just fetches everything from Git, the latest host variables and whatnot, and then it runs Ansible playbook and just pushes everything out to network devices. Yeah, so if you put everything together, it looks like this, a bunch of boxes, blah. It's not like super complicated. But obviously, I'm missing some stuff, because I think right now, if my team members are watching this, they'll be like, oh, you forgot this, you forgot that. I did forget a lot of stuff in those boxes, because if you talk about IP transit, obviously you have to do like validations for like the ASN, AS sets. We sync from peering DB, like the customer's prefix limits, update write DB, the AS sets on our AS sets on write DB. We have to maintain like prefix lists to filter them and whatnot. And we also have a DDoS platform. So if the customer for the IP transit also has DDoS with us, then we have to remember to push the prefixes to this DDoS platform, or to enable DDoS-specific BGP community for their sessions. And of course, there's also things like billing, yada, yada, yada. So what I'm actually trying to get at is that there's some inherent complexity in all these things that we're trying to do. I mean, when we talk about complexity in software, there are like various ways to measure it. But I'm like super basic, so we just go with lines of code, right? So right here you see Inter.link's the first commit in this repository that we have, 2022 February, 60 lines of commit. I actually looked it up just out of curiosity, and yeah, it's just a bunch of markdown actually. And within the first year, we added like 50,000 lines of code. And then if you look from 23 to 24, we added another 120,000 lines of code. And then last year, so 24 to 25, we added about 60 to 70,000. So a little bit less crazy. But this is a staggering number, right? So if you talk about 120,000 lines of code per year, that is 10,000 lines of code per month. So this is a lot of stuff that's going into our repository. So what is this talk actually about? As our software is growing with more products, more features, and more automation, the way we work with our software also has to evolve. So this is what this is about. So it is about software, obviously, and I know I get the irony when DENOG, and I'm talking about software. So if you have to use the bathroom now is also a good time. If you don't want to hear about any of this, I wouldn't be offended. But so yeah, if not, let's get on to the story. So chapter 1, the beginnings. So when Inter.link first started, we're talking about roughly here, 2022 to 2023, where we're putting out our first 50,000 lines of code. We basically, this is just the start, right? I just want to give a disclaimer. I kind of joined a bit later, so some of the stories here might not be entirely true. Well, more or less, but maybe someone earlier in Inter.link might be screaming at me also, like, this is not what happened. But who cares? I'm giving the talk, right? So when we first started, you first start a project, you start looking around, hey, what can we use, what can we do? And yeah, we just went with like, we use Django because we are essentially a Python shop. We use Docker for packaging our stuff. We use Ansible for configuring the devices. GitLab store all our code. For the front end, we have React. For some smaller APIs, we use Flask. I'm missing out a whole bunch of logos here too, right? Like Netbox, whatever. But the point here is that we're just using like what we consider, or what I consider, a very standard suite of tools, right? This is fairly like decently modern stack, nothing too crazy, nothing so-called legacy. So yeah, we kind of started doing this, started writing the code, and then of course, at some point, we have to bring this code into production. So it looks like this, right? Developers hacking away, and then they just push the code to GitLab, and then GitLab's like, okay, let me just deploy this stuff to Kubernetes, and then we call it a day. Yeah, maybe not. So when you push changes to GitLab right now today, what we're trying to do is we have to test it, right? So we run a pipeline. We run a pipeline that looks roughly like this. You build the packages, and then you start testing it. So we use Python, so like PyTest. We use black ISORT for linting, MyPy for type checks and whatnot. And then once that's done, we deploy this out to Kubernetes. So deploy the whole environment to Kubernetes. And then at the last stage, we run E2E tests. So things that test the entire environment, so more tests. And of course, at some point, once you do that, then somebody comes along and say, oh, I approve your merge request or pull request if you're in GitHub world. And then once that's done, then you just try to bring it out into production. So same thing, once you merge into main branch, we built everything again, we test everything again, just to make sure everything got merged properly. And then we deployed to staging. Same thing, Kubernetes, so just like kubectl apply, whatever. But then, at that point in time, we have a gate. So it goes like, are you sure you want to continue? And somebody actually has to click it, right? So, I mean, this all seems like sort of reasonable. Obviously, it isn't, because then I wouldn't be giving a talk here. The thing is, whenever we merge stuff, and then all these changes gets deployed into staging, then we need someone to press a button for this to go into production. And this is called a release, and this is obviously manual, because somebody has to be there to do something, to trigger it. And this is kind of how it looks like back then on our Slack channel. So I kind of pulled this out. So from the stand-up meeting, who's going to take over the release today? And then some guys just like, I'm tired of this. So, you know, how about let's go to shortstraw.com. And then, of course, on your team, there's someone's going to say, oh, yeah, you know, if no one volunteers, I'll do it. And then with the sweat, smiley, emoji kind of thing. So I think he doesn't really want to do it. And you can see this goes on for like 18 replies. So obviously, we're not working. We're just talking about work. And what the heck is this draw.shortstraw.com? It's basically, if you go there, it says, if you can't decide who should do the unpleasant task, then we draw straws to pick, right, to decide. So that's what draw.shortstraw.com is. So obviously, this manual release is an unpleasant task. The other thing we had, once we set everything up, was that people were complaining that the pipelines were slow. We measured this. You're not supposed to be able to read the small numbers, but essentially the whole pipeline for making a change goes about 19 to 25 minutes. So yeah, I mean, you know, it's like long enough that I could, you know, do my lunch or something. But it's not like, in the grand scheme of things, and retrospectively, it's not super long. We'll talk more about it later. But there's something that's even worse than having slow pipelines. It's basically the pipelines that try to gaslight you. So it kind of looks like this. We're talking about unreliable pipelines, right? So you have people, you have your developer locally, it's like hacking a bunch of stuff, and then they put it on GitLab, and GitLab's like, oh, everything is green, this is perfect. But the developer locally is still like, no, I don't think so. There's something wrong with it. Or you could have it the other way around, right? Oh, it worked for me locally, but then when I put it on GitLab, everything is red. And what people do after that is they just go to GitLab, they click retry, and then they just start praying, right? This is what we did for a while. So my hot take actually is not really a hot take. I think it's more like a warm take, because I think a lot of people would agree with this. This is not just about the tech, right? You can pick a very modern stack, but you can do like a lot of not so great stuff with it. So we move on, right? Moving on, you know, Inter.link scrolling a bit more. And we move on to the stage where we started adding like more and more code. And this is like the problems that we talked about is like getting even worse. So we talk about manual release. Yeah, it's not great. People just talk about who's going to do it, blah, blah, blah. But it's not just about that, because it also really slows down our velocity. So on an average week, it could look like this. People are putting out features, bug releases, but everything gets stuck on staging. So these are basically features, bug releases that the customers cannot see. The other thing, of course, it's a button. I said it's a button, but basically there is like a procedure to doing this, right? You have to go check this, and then click the button here, and then check that, and then whatever. So there is a process to it, so it takes time for people to do it. And if you find a bug and you want to do a hot fix, it's also terrible, because now you have to go through all the unreliable pipelines, and then you have to go in, and then you fix the thing. Finally, it merges, and then you have to do another manual release. So if you go on Slack and you search release hotfix, yeah, it's like full of it. There's also like a little side effect about having hotfixes that people don't want to do. It's like people try to find workarounds for it. So it's like, oh, I can be smart about this. If I change the data here, then the bug doesn't get triggered. So people started doing workarounds too, which is obviously a really bad thing as well. Another issue, so if you put out 5, 6 features, bug fixes, changes all at the same time, it's very hard to find a bug. Because if you look at, so you made so many changes, now there's a bug, where did it come from? It's like a bit harder to find it, and like maybe it's just there, maybe it's an interaction between 2 different changes and whatnot. So you get these kind of problems. So maybe you're like, wow, all this talk, why not just get rid of the stupid button, right? You have the stuff there, just get rid of the button, things would just go, right? Yeah, unfortunately, it's not so easy. The thing is, our pipelines, as I said, were not reliable. So what this means is, if we remove the button, we just ship like bugs even faster, which is not really what we want. And of course, part of it is you want to make sure that your pipelines also get to run more tests to cover your code base a bit better. So we need to take a little bit of a detour, right? So yeah, with that, we go on to the next chapter. In case the chapter's title is not obvious enough, we are talking about unreliable pipelines here. So where do we start? It's like people tell you it's unreliable, what do you do? Very simple, exactly where it is. So whenever a developer says, this thing worked locally, but GitLab doesn't agree, then you just stop them. And it's like, okay, what actually failed? You start asking questions. Like, what actually failed here? What is it that you think works? And what is it that GitLab thinks doesn't work? And you ask, like, why does it have different results? And also from me as a third party, like, can I actually reproduce this locally? Because if you cannot reproduce this, then you're going to have a lot, like, it will be very difficult to fix it. So what we found out over time is that, you know, you have developers on their local doing a bunch of stuff, so maybe they do like Docker build, but on GitLab you do something different, like Docker compose build. Or they do PyTest, they use like the local environment, but on GitLab we do something different. We go into the containers, Docker compose exec, and then run the PyTest. So this is not great. So if you run any science experiment, you need to be able to control for your variables. And that's exactly what we try to do. So after a while, we're like, all right, developers, GitLab, you have to do the same stuff. So if you want to build, this is how you build. If you want to do PyTest, this is how you do PyTest, etc. And of course, to make things a bit more user-friendly, we just wrap it around in a script. So Titan is just the internal name we have for our stack. But if you write a bash script for it, it could be a makefile, whatever. You standardize it, and you document it, and people will start using it. So now, when developers come to you and say, oh, I ran it, it doesn't work, at least you have something to work with. You know they ran the same stuff. You can figure out things. It's easier for you to figure out what went wrong. Or it's, like I said, it's also easier for documentation. And also, if something breaks on the pipeline, you know exactly what you need to run locally, because you can run the same stuff to try to reproduce it. So it makes it much easier to debug. So the point I'm getting at is you need basically one way to build your stuff, to do package versioning, to deploy, to lint, to test, all that kind of stuff. So have only one way. There's an asterisk there, but basically not everything would be one way, but that's just, yeah, details. So I don't know if you remember this part of it. So when we run like this integration tests, we're trying to test everything in this flow. And what we do is we spin up test environments. So it looks good. It's like kind of isolated, so different merge requests has different test environments. But in reality, it's not exactly like that, because we could share, for example, the same Git resource. We could be sharing the same ERP environment. And this makes things really tricky, because when we write code, we write with the assumption that that the code has access to the resource, and they're the only ones who have the access. But when you start mixing different environments, trying to write over each other, stepping over each other's toes, you're going to get basically a lot of bugs. So this is what happened with us, because we had pipelines that passes sometimes when that's the only test environment. But then when you have like 5 developers trying to run tests at the same time, then you get this sort of issue. So you got to try to isolate them. For example, for Git, it could be as simple as just making sure people write to a branch for every single merge request for different test environments. For the ERP, for us, it was a bit more complicated. Here I just said, oh, you can just kind of isolate them by customers. So different services belong to different customers. You run tests on different customers. In reality, it was a bit more complicated than that, but those are just details. The point I'm trying to make is that you should just try to make sure you isolate everything properly in your test environments. Whether this isolation is like a fake or virtual isolation, like you should just do that. Otherwise, you're gonna have problems. Another thing that we found was flakiness. So when GitLab deploys out to Kubernetes, so this is for testing, right? What we do to be able to run HTTP requests to run our tests is that we actually do this thing called port forwarding. This is basically a tunnel from like GitLab environment into our Kubernetes cluster. And then once you do a port forward, then you could do something like PyTest, like localhost 80, and it just runs tests. But turns out this feature from Kubernetes is not very good, not very well implemented. If you just go online and search, it's like, yeah, it's horrible. So this flakiness, like this tunnel keeps breaking for us. And after a while, you kind of just bypass it. So what we did was instead of having the tests run from GitLab to Kubernetes, we just schedule a job on Kubernetes that runs the test. So things are running within the cluster, and then wait for it, and then after a while, you get the results back. And that's it. So like what we're trying to say is we just want to get rid of these sort of flakiness. But of course, like you cannot control for all of it. Some of them will always be there. For example, if we depend on an ERP, we don't host the ERP, of course. These services could be down, so you can do things like automated retries and whatnot. But you have to kind of balance it, right? So you can say, I want to run a GitLab instance for this, like our own GitLab instance for this. You have to ask yourself and figure out whether it's actually worth the work. So yeah, when it gets bad enough, then do it. Otherwise, nope. So pipelines are more reliable now. The next bit of it, my code's compiling. So obviously, this doesn't really apply to us. But what we're really talking about is just slow pipelines. So how slow are we talking about? I think it was something like this. So like 5 minutes to build, 4 minutes for unit test, 4 minutes for deployment, and then like 15 minutes for E2E test. So the first point is you got to measure it. Otherwise, you don't know where to improve. And after measuring it, obviously, you go for the ones that takes the most time. So basically, the E2E tests. So what does that really look like? For us, E2E tests is trying to test everything in this flow. So for example, I say I want to provision IP transit. I want to deprovision IP transit. We also have IP access, flex Ethernet, DDoS. So we want to do all of that. At some point in time, we also introduced lag. We added lag support. So we're also going to want to test that too. What about aggregated commit? So we have this feature that allows you to aggregate your commit across different services. Yeah, we have to test that too. What about reusing ports? Yeah, we have to test that too. And you want to test this also in different combinations, right? We talk about lag, we talk about port reuse. What about lag reuse? So this combination starts to explode like very quickly. And what happens is every time you add a feature, you can see the pipelines getting slower. So that's not great. So what we did, we just tried to parallelize everything. So I show you a Cortex backend API. So this Cortex backend API also actually has a queue and a bunch of workers. So it's very simple. Just create a whole bunch of workers, and you're done, right? So multiple workers takes on multiple tasks. Things run faster. And you can do it something like this. So obviously, when you say deprovision IP transit, it cannot be parallelized because it depends on provision IP transit. So this is how you can kind of send in the work streams, so to speak. Or here I wrote parallelizable units. And then when you add more stuff, then you just add more workers, right? Unfortunately, not really, because in our systems, when we're trying to write the netbox, this is something that we have to control access to. So we cannot have different workers trying to figure out, for example, if there's a port in a certain device. Otherwise, you just get into like concurrency problems. So we have a lock for this. So if you just keep increasing the workers, you're not going to get much faster because of that. So what can we do? Very simple. We just parallelize by environments. So we got good from the last chapter at creating environments. So let's create more environments. So if you make one MR, let's have a few of different environments, and then we start doing tests on all of them. Yeah, I mean, there are of course challenges to doing this. So first thing, independent tests. So the test has to be independent for you to be able to parallelize them. What I mean is that if you have dependencies, you cannot run them together at the same time. Also, you have to be good at spinning up environments. Otherwise, this is just going to make your setup way more complicated. And we also ran into a bunch of concurrency bugs. They're not super fun to debug, but yeah. Also, if you talk about slow pipelines, there's a whole other bunch of things you can do. You know, we got on like newer hardware. You know, like try to figure out how to use less test data, you know, slimmer images, blah, blah, blah. So there are also a bunch of other things you can do to try to make your pipelines a bit faster. So the tip here is write independent tests. You don't have to parallelize everything from the start because it could be just making things more complicated for no reasons. But if you start by writing your test, making your test independent, then it will be easier for you to parallelize things down the road when you need to. So with that out of the way, go back to this, trying to get rid of the button, right? Saying goodbye to this. Yeah, can we actually get rid of the button now? Yeah, sort of, right? But you have to just remember a couple of things. You have to make sure that when you're doing deployments that there's no service disruption. Otherwise, if 10 MRs get merged in one day, then your service goes down 10 times. Not great. You have to make sure how to handle like breaking changes. So when you rename a column on the database, like how do you actually handle this? And also, because you are making changes so quickly all the time, you have to make sure that you have good monitoring to know when something breaks. But of course, you also have to have someone watching it, right? You cannot just, I have monitoring, it's like alerting my channels like 10 times a day or something, and nobody's looking at it. That's like kind of pointless. Another thing that is really useful to have is how fast you can roll back these changes. It doesn't have to be like a split second, but just knowing that like operationally how to do it and how fast you can do it, it's good. So my hot take for this is, you know, try to adopt this like method of continuous delivery. So no manual buttons, no manual release by default. So you don't have to go through this pain of trying to get rid of all the different issues first before you get there. But there's an asterisk to it as well, because it depends, right? Like if you're doing software for, I don't know, if you're trying to push a new iOS update to my phone, like I don't want this to be delivered to me every second, like 10 times a day. So you have to see how it works in your context. Yeah, so is this like the end of everything? Did we fix everything? Yeah, I mean, let's do a bit of stock taking, right? So how are we today? Pipelines are not actually that much faster, but they run a lot more tests, so that's kind of nice. Pipelines do still fail, but we actually know why, and we can try to mitigate them. Also, obviously, we stopped using this. So I show you this complexity slide. This is February 2025. So November 2025, now right here we are today, November 2025. Within this year, we already added another 60,000 lines of code. So my hot take is this never ends. So where do we go from here if this never ends? Because we're going to want to have more products, more features. Doesn't this mean more tests? Well, kind of. But we can try to do better. So we don't have to run tests for everything every time we make a small change. Can we run our tests more selectively? Or can we just delete tests? Because sometimes people just keep adding stuff to it. But if you go back and review your tests, maybe you're like, oh, they're just testing for the same stuff. There's no need for it. Can we refactor our code so that we don't have to write the test? So for example, we look at products like IP transit, IP access. There are a lot of very similar things to it. Can we refactor it so we don't have to test them twice? Another thing we want to do is just have more test coverage, especially in this area that I was just putting there. This is something nice to have. So in the end, we're trying to deliver network services. So yeah, it would be good if after doing all the weird JSON-y stuff, that in the end, the network devices do get configured correctly. And finally, I think this is the point of it. I keep showing you graphs of us adding more and more lines of code. But the truth is, actually, maybe we should try to reduce the complexity. This could be removing stuff in the picture. So like, hey, let's get rid of Git. Let's get rid of using Git, not get rid of Git. Hey, maybe not have logs. Is that possible? Yeah, that could be possible. Could we refactor our code base so it has less code? You know, that kind of stuff. So we don't want to keep, so for every product we add, we don't want to add 10,000 lines of code. It's not something that will scale for us in the long run. So that's trying to look at this from also another perspective. Yeah, so with that, actually, that's all I have for you. So thank you. And I know it's lunchtime.
Thank you, Po, for your presentation. And again, I see already one hand rising.
Well, thank you for this very interesting talk. I'm quite interested in the bottom right corner of your diagram of the pipeline. Exactly, that's where you deploy the stuff to the hardware. And the question is, how much of that do you simulate, and how big is your environment of real hardware where you test if the deployment is successful?
So, I mean, if you saw towards the end, there's we want more test coverage there, as far as you can imagine. But at least what we have today for that setup, so we have a container lab set up for us to be able to like just test some stuff. We have a lab set up with actual hardware also to also test some stuff, because there's some stuff that container lab doesn't allow us to do. And then finally, we have like our actual devices. So how much tests are there? Basically, I would say not enough, but then this is just the paranoid me always speaking like we want to always test more. For example, like I said, I gloss over this very quickly towards the end. When I say I create an IP transit, the result of all this stuff that happened is that did the BGP session come up in the end? And that's, to be frank, like something we cannot answer today. So that's what we want to answer by adding all these tests. So this is the end result of all that configuration. Did we get it? So yeah, did that answer your question, sort of? Yeah, if you want to know more, we can also talk more about it.
Thanks again. And thank you, everyone, for being here. This was our last session before the lunch break. We don't have time for more questions, unfortunately. So if you've got any more questions, I guess you're around today and tomorrow as well. So feel free to find Po to ask the questions in a face-to-face meeting. And hope to see you later again. Thank you.
Thank you.